pull up a chair, take out the oxygen, and join the discussion.
You've just stepped into Life Unculturable,
the world where conversations grow faster than colonies.
We're your hosts, Sam and Julia, scientists by day,
podcasters by night,
and professional oxygen avoiders 24/7. Join us in exploring the science of microbes that thrive in the absence of oxygen on Life Unculturable.
So, hello and welcome to the next episode of Life Unculturable. Today, it's again Sam and me in our transatlantic little chambers, because Sam sits still in Stillwater, Oklahoma, and I'm sitting in Innsbruck, Austria, in a different kind of chamber.
Yeah, so we're gonna pretend that I'm more in a proper anaerobic chamber, and you can be in like an anaerobic jar. We'll settle for that.
Yeah,
settle for that.
Because you're in a proper podcast chamber, and I'm just in my little office chamber over here. That's a fair comparison. Nice.
That's true. But as is the case with many anaerobic chambers, mine does not quite come with the illustrious view that you have outside your windows of the mountains and the trees.
That is true.
I'm just looking at bleak and utter emptiness in here.
Well, you're looking at me, but thank you.
Oh my God. Well, to be fair, I was talking about the fact that there's no windows in here.
Sure you were, Sam. Sure.
I'll let you psychologically delve into that however you'd like to. But yeah, welcome back everybody to our, is this the 13th episode, I think? Yeah, 13 episodes in. It's crazy to think that we've made it this far.
Yes. Oh my God, yes.
Yeah. I know when like on Spotify when I hop on there, it's at the point where it only displays like 10 episodes, and then you have to go to like page number 2 to see the 11th or whatever. And I'm like, wow, look at that. Kind of like when I got to sign into something and they make me spin the little wheel to get my birth year. And I'm like, oh my God, it just keeps going and going and going.
But to be fair, this one with the podcast episodes feels better than spinning the wheel until you get to your birth year.
Yes, completely agree. So, Julia, how are things in Austria?
I love it. I love being back in Innsbruck. Innsbruck is just a very beautiful town, very different from Oklahoma. I love being back, but I still miss you guys a lot. So yeah, I wish we could just like pull everything together or beam people around. Like beaming would be a cool technology.
Yeah. A little teleportation action. That'd be a wild scenario. See, then if we could teleport things, we could just teleport autoclaves in and out of the lab, That would be
So maybe one autoclave anywhere in the world could work at that one time, and then everybody tries to teleport it into their lab.
Exactly. Yeah, it'd be like a common resource that everyone would want all the time, everywhere. Oh.
Yeah. So, time since last autoclave ran 2 minutes, and it wasn't me this time.
I was just about to say we've made it a whopping like 2 or 3 minutes into this episode, and it's already on my mind. Oh.
How is the autoclave, by the way?
Well, let me formulate a politically correct answer here. The autoclave is trying its best. No, the new one, the smaller one that's in our lab, it is functioning very, very well, and it does a lot because it's the only one in the building that's operational. The larger autoclaves are still in a state of utter dismay, and I'm not sure if they're ever going to recover.
Oh my God.
Yeah.
Yeah, those were really old, right? I mean, they were installed in 2024. So that's like
they're ancient.
They're ancient.
Yeah, if they were like a labradoodle, it'd be an adult by now. But that's okay. So we've got our little autoclave is still functioning. Knock on wood. For now, I got nothing but good things to say about our little autoclave.
Nice. We'll keep the fingers crossed for this little guy holding on for dear life, autoclaving the whole building.
I know.
Man.
I know. But that is one very important piece of lab equipment, the old autoclave. But today, Julia, I think we're going to be not necessarily talking about a piece of lab equipment, although it involves pieces of lab equipment, but something that's pretty near and dear to our hearts, probably yours more than mine, is this idea of microscopy. And so I think before we delve in, I was going to give a quick shout out to Lisa. Lisa, I know you're listening, and I would have loved to have had you on this episode. I appreciate you saying no, but you're welcome anytime.
You are our favorite microscopy person.
Oh, hands down. Sorry, Brent, but hands down. we got favorites, you know. I've got 2 kids. I know I've got a favorite. Okay. So Lisa.
And the favorite is Lisa.
Your favorite is Lisa. There we go. So anytime you're welcome to come on. We'd love to chat with you. But yeah, microscopy. And do you have feelings towards microscopy? Are you a big fan of microscopy?
I have very big feelings towards microscopy. I do.
Good big feelings, bad big feelings?
I mean, as all things in life come with like 2 sides to a coin, right? If you have very big feeling one way, there are days when you have a very big feeling the other direction.
Nonsense.
So yeah, big love for microscopy, goes both ways. But yes, I love microscopy. I love looking at a side of the world that we don't get to see with our own eyes without using a microscope. I love seeing even bacteria. Like I love just seeing anything through the microscope. But of course, fungi are prettier. But yeah, I truly love when I get to do microscopy, but there are certain aspects of some microscopy techniques that are a little bit frustrating at times.
I like how you said that, a world that we don't typically get to see, because I think for me, microscopy is probably what originally led me to fall in love with microbiology. I know, like my experience in high school, so my secondary education, it was largely read the textbook, take the test. There weren't like labs or sort of hands-on type activities, especially in the biological sciences. And so for me, like I didn't really use microscopes at all until I was at university. And I remember still to this day being in a microbiology lab and seeing cells for like the first time. And it's all of these little, you know, blobs of stuff. And it's not like it was a proper gram stain or it was a particular, you know, it was probably just like a wet mount of the pond outside. And I was looking at algae and other type of stuff. But I remember seeing all these little things, and it was so fascinating to me that it's like you said, it's this hidden world that's all around us, yet it's completely almost oblivious in a way. It's invisible. We don't see it, so we probably don't think about it. And but yeah, I absolutely loved getting to look under the scope and seeing just things that I'd never seen before. That was so cool.
Same. I completely agree.
Yeah. What I wanted to ask you is, why in the world does microscopy still matter in 2026? Right? Like, why do we still find ourselves doing microscopy?
You mean other than the pure fascination with like microorganisms and looking at them? Or you mean like scientifically?
Oh, either way you'd like to take it. I think oftentimes I think there's a movement away from things that are more difficult to things that are a little bit easier to get you more information. And I'm not saying that microscopy is inherently difficult, but I think it requires a particular set of skills, as Liam Neeson would say.
And equipment.
Yeah, and equipment. And sometimes that equipment is very, very expensive. And so I'm curious what, like, do you think microscopy is ever going to go away? Are we still going to be doing microscopy in 50 years, or, you know, what do you think?
I mean, so I think microscopy itself will never really go away, because if we think outside of our little microbiology bubble for a second, I think microscopy in histology is like really important. Like medicine, like trying to figure out a diagnosis, those people still use microscopy a lot. But even I feel like in our field, microscopy will never go away. Of course, microscopy itself is like time consuming. It requires equipment that is very expensive. And then the data you get, like the images you look at, are very much just qualitative. Like I can look at an image and see something, and you look at it and you see something different, or you see the same thing, but you describe it differently. So it's not really standardizable. And comparing microscopy images or the data that we get out of them between labs can sometimes be difficult because of that. But still, I think microscopy in a lot of ways still offers a lot of important information, especially in anaerobic fungi research, although I do think that it should not be the gold standard it used to be, and it isn't, but it's a necessary thing to do. But yeah, I don't think it will go away in anaerobic fungi research, and I don't think it will go away in other kinds of research. Microscopy in general.
Yeah.
Some microscopy techniques might be, I don't know, discontinued.
Yeah, I completely agree with you. I don't think microscopy is going anywhere, but I think the way that we interface with it might change.
Yes.
Like I know while I was at the ASM, American Society for Microbiology conference in DC this past, well, I guess it was this month, here in June 2026, there were a lot of like automation of fill in the blank, automated plating, automated slide staining, automated, like you mentioned, histology stuff, a lot of things like that. And so I do see a world in which maybe that happens where you set your slide on the little deal and then it goes through and stains it like for you automatically and that sort of thing. And then maybe even too, like the focusing in of the microscope, like that might become computational. Maybe we've got like AI or something scanning through the images and inferring like what is seen. But I don't see microscopy in general going away. Man, I'm trying to think. It was for a brief bit of time, one of my favorite and then also my least favorite things, microscopologically speaking, was using a hemocytometer. I don't know if you've ever experienced the joy of working with one of those. But at first it was fascinating, the idea that like I could take this sample, put, certain amount of microliters on this little hemocytometer slide thing. And then, you're looking at it under the scope and it's got the little grid lines that are mathematically a certain, area. And then you're just counting the cells in certain grid patterns. And then you plug that into an equation and out pops, I've got whatever, 2.7 times 10 to the 9 cells or whatever it is per a certain volume. I thought that was so cool. And then I had to do it more. It's fun for like the first 10 times. And then you're like, I'm over it. I don't want to do this anymore.
Yes, you sit there on the microscope with your little clicker thing and you count and count and count. And it's like, okay. But yeah, it's fun. It's fun the first couple times. Yeah. I agree.
Okay. Well, we can agree on that then. We might not agree on much, but we can agree on that. And then you kind of teased this a second ago, Julia, talking about how you think that definitely in AGF research that microscopy is probably not going anywhere. But I wondered if we could chat for a bit about just how do we use microscopy in our research. And I know that in past episodes you've touched on a couple of things microscopy adjacent to AGF, and that probably deserves an episode on its own, because there is quite a bit that I think goes into looking at all of the different structures and the importance of the structures and things like that. But I'm curious if you'd like to offer up something for, how you use microscopy regarding like AGF.
Sure, yeah. I can give like a brief summary of what we're doing. So in AGF taxonomy, so differentiating between different species of AGF. We're looking at the talus morphology is what we call it, if it's filamentous or bulbous, if it has like zoospores that have just one flagellum or multiple flagella and stuff like that. So microscopy was really important in the beginning to differentiate between the different species. But of course, with the sequencing technology and how that got cheaper over time and stuff like that, and better, of course, we started to move towards that sequencing technology for differentiating anaerobic fungi species. And it is usually a bit more robust because, also like we have 25 genera of AGF, and I think 13 of them have a filamentous monocentric thallus with like monoflagellated zoospores, so the same morphology basically. And then you just can't differentiate between them as easily. It becomes very qualitative and very dependent on the person. But that said, microscopy still plays a huge role because we have some species that are their sequence in the macroregions that we use are very, very similar. But when you look at them under the microscope, they look completely different. So that's why I think microscopy and anaerobic fungi research might not go away as quickly as maybe in other research areas. So it's really important to still look at the biology and the actual like fungus and not just that sequence data. How is it in your area? Because I feel like bacteria, they're round. They might be rods, they might be spirals, but they're all like very similar, despite them being like, I don't know how many thousand different species.
Yeah, no, that's a fantastic point. And so in terms of, looking at something abstract or fascinating regarding their cell shape, you pretty much hit the nail on the head. There's like 3 or 4 shapes that they can be. And of course there's different like arrangements, right? Like there can be diploids, so like 2 circles stuck together, tetrads, or there can be clusters or chains or that type of stuff. But in general, it's like, are you a circle? Are you a rod? Or do you look like a spring? And there's a little bit of, there's like coccobacilli. And so there's, some that are kind of in between the two. But in general, yeah, there's not a lot of diversity there. And so I would say probably for us, royal us here, bacteriology folks, when I'm looking at the cell, like, is the arrangement important? Yeah, it's important. But probably more what we're getting out of it is like the cell size. There might be, I don't know, 500 different types of rod-shaped bacteria, but they'll have like a range of size. Like, for instance, certain ones are only going to be, say, maybe 2 to 2.5 micrometers in length, whereas others, they might be between 0.75 to 1 or something like that. They might be a small rod versus a large rod, or they might be thicker or thinner, that sort of thing. But I will say one of the most important things probably for us is one of the more fundamental stains, I would say, in microbiology that almost everybody does if you take a microbiology lab course, and that's the gram stain, right? One of the very first things is like, hey, what does the cell wall structure of this bacterium look like? And that's something that I don't think we're ever getting away from. It's like, is it pink or is it purple? Like, that's one of the first, questions. And even beyond that, there's some other stuff too. Like, does it form an endospore? Does it, produce a capsule? Can we do a flagellum stain? And so there's a lot of stuff like that we still do. And even like simple stains and negative stains, trying to just get more at, again, what is the overall shape and structure of this isolate or this taxon. And so I think, yeah, those are definitely important, but I think they probably play a slightly less important role for me in my particular niche of research than they do yours. Because I still marvel at, like, in your AGF manuscripts, the figure 1, right, where it's 14,000 very beautiful images, and some of them are less probably technical than others, but nonetheless, it's like all of these different structures and all of these different, with the DAPI and without the DAPI and with the SEM and with the confocal, and it's like all over the, I think Mustafa put it beautifully the other day in a lab meeting. He was talking to one of the grad students in the lab, and he was like, now this figure should tell like a story, and it should be about, like, the life cycle of this thing, like start to finish, more or less, as it's at the end, releasing the spores and whatnot. And like, that was a really cool way to look at it. But I don't find, there are obviously some manuscripts closer to me that are more, more heavy on the microscopy, but for the most part, not so much. And at least not to that extent where it's like, oh, we have, 20 panel figure that's got, all of these very intricate measurements and structures like you guys have. So I don't think it's necessarily quite to that extent. Although I will say there is a manuscript currently in review coming back for like round, I don't even know at this point, 3 or 4. Anywho, moral of the story is that people in the field are still interested in all things microscopy.
They are. Given that we are like 40 minutes into this episode, do you think it's time for a lab yet? Is there something you want to get off your chest this time, Sam?
So as I was putting this together, I was trying to think about like a specific microscopically inclined set of lab yaps, and I bounced an idea off the illustrious Ty Young, our standout star undergrad in the lab, currently the only one. But nonetheless, he's in the lab, so shout out Ty if you're listening to this. And he literally told me, he was like, it's like trying to teach a monkey how to use a saw. And I was like, what? I'm like, what a quote, buddy. And so it made me think of my time at the University of Oklahoma, where when I was in my, like, earning my PhD, and I was a graduate teaching assistant. And so I was, helping undergrads through their introductory microbiology labs. We would spend a solid probably month or so on like microscopy, introduction to the scope, the parts of the scope, all of the basic stains and how to focus and, do all of that sort of stuff. And sometimes, I will not lie to you, it felt like I just wanted to jump out of the building and end it all. Like, it was rough at times, especially at first with these students. And it's not like it's their fault. So I'm not trying to blame, the graduating class of 20, whatever. But I mean, oncoming traffic can look appealing when you're trying to teach undergrads how to do microscopy. And I think I will blame part of that on like the secondary education system here. Because for me, again, like, I didn't really get to use a scope until I was in university. And I imagine there are lots of other students that are probably in a similar situation. And, there's just like with anything, when you're trying to learn calculus or you're trying to, do whatever, there are growing pains at first. And I can recall in these teaching labs, like, not necessarily the very first day of the microscopy stuff, because that's where we just like stick pond water under a slide and let them look at like, 10, 40x, and that's the end of it. But it's when they have to get to like oil immersion and really like find the stuff that they're looking for. That's when everybody has problems. And I got 99 problems, and they all undergrads. And oh my God. And so it'd be a class with like, I think it was capped at 24 students or something like that. And so of the 24 students, probably 20 of them are really struggling. And trying to, in a, certain hour period, go around and give everybody enough time and attention and help them focus in on things and find things and troubleshoot why their scope isn't working. And I'm like, have you even turned the light source on? No. Like, what is happening here? Of course you don't see anything, Like, why don't I see anything? And it's like, well, you're currently between objectives, so that's why you don't see anything. Like, click that thing until it stops, like just all of this stuff. And I'm like, I always used to dread those times in the intro micro labs. And so for me, that was tough. And and maybe it was just the volume. Like, if I only had to do that with 5 people at one time, maybe that would be a little bit easier. But trying to do it with, 24 people, and again, 20 of them have never touched a microscope before, like, that was tough. But yeah, so that's probably me. Man, it's hard sometimes to teach an old dog a new trick.
Oh yeah. And microscopy, for some reason, it is also really complex. I mean, maybe our listeners have never used a microscope and they were like, what is so complicated about using a magnifying glass? But it has like all of these different moving parts that need to align, like the different lenses that you need to align correctly, and then like to even find what you're looking for. And then I'm always like really bummed when my students get really excited about something they see in the scope, and you're like, oh, I have to show you this thing. It's really cool. And then I look at it and it's like, dude, that's an air bubble. You're looking at an air bubble.
Yes, it's an air bubble. I'm so glad that you brought this up, because especially when we get down to the oil immersion thing and they start to see those like air bubbles zooming across the screen, and they're like, Sam, I can see these little circles, but I can't see the, whatever it is we're looking at. And then I'll come over and I'll look and I'll be like, okay, this lovely future trauma surgeon is looking at air bubbles right now. And I will just say to them, like, don't call your mom after class and tell them you saw anything really cool. Like, this is just an air bubble. gotta go a little bit further,
Yeah. But that's always so disheartening because they're so excited about it, and you're the one that's like burst their bubble, literally. Like,
yeah. And then I'd see microscopes where there was like 2 inches between the 100x objective and the stage, and I'm like, gang, we're not looking at nothing right now. Like, what are we doing? You might as well have a telescope out here. Like, what is going on?
To be fair to those people, like I started out the same way, and it's so hard to get something in focus the first couple of times. And then also when you're working, it depends on what magnification you're working on. But anyways, it's like this little wheel that you turn, and you turn it like less than, I don't know, 1/10 of a millimeter, and it like screws through all of those planes, and you don't get anything like that takes some motor skills to learn at first.
Yes.
And now I'm like, yeah. But once you've done it a couple of times, you like pop the slide in, and then you don't even use the fine skills at first, right? You know approximately what distance, you know what it should look like, and you just go for it.
Mm-hmm. Mm-hmm. Yeah, no, you're exactly right. Exactly right. I think it's just a practice thing, and but yeah, totally. I started out the same way too. I had absolutely no idea what I was doing. I broke slides. I broke everything. It was not good. It was not good at all.
Did you have like a big mishap that you still remember in microscopy?
Oh, microscopy specifically. Yeah, I think my big mishap was so 2 of them that I can think of. One is like breaking the slide. So I was on probably the oil immersion objective. The sort of, if you're looking at a microscope, the objectives are essentially like these little tubes that stick down from the top of the microscope, and as you go from like the smallest one to the biggest one, it's like you get more and more magnification in a nutshell. And so on sort of those longer objectives, you don't need to use what's called the coarse focus. The coarse focus moves the stage up and down where your slide is like a whole bunch. And the fine focus, as the name implies, it moves the stage up and down not as much. And microscopes see at depth, and that's why you need to move the stage like up and down as you're trying to look at whatever it is that's on your slide. And so I, for whatever reason, had the thing on one of the larger objectives, and I just crushed that sucker with the coarse objective and just broke the slide in half. And I would like to pretend that I only did that once, but I was a repeat offender.
Did the objective survive? Because like the 100x has like this little bubble lens on the bottom.
Yeah, it did. I don't know how it did, but yeah, somehow it survived. So shout out to whatever glass company made that objective lens. They did a fantastic, like diamond or something. So, but that was bad. And then I realized that you could pull the ocular lens out of the microscope. And so ocular lens, those of you that are like, what in the heck are all these parts of the microscope? There's a stage and there's the objectives and an ocular lens and the iris. And anywho, there's tons of parts to the microscope. Think of the ocular lens as like binoculars. They're like the things that you stick up next to your eyeballs. And the way that most microscopes in like a teaching lab or something like this work is it's a compound microscope, meaning that there's, multiple lenses that you're looking through to increase your magnification as you're trying to look at this slide. And so the ocular lens is like the beginning of that. I realized that you could turn them like left and right, clockwise and counterclockwise to try to account for various, discrepancies with like your own eyeballs to try to make the thing more clear for you to see. And then I just pulled that sucker out because I didn't realize that it just came right out. And I think the best way that I could describe this is that it went across the floor like a bowling ball.
Shoot.
Yeah. So that happened again, to my knowledge. It was fine. But yeah, it kind of reminds me of that scene in Pirates of the Caribbean where that dude's going after his eyeball. It's just rolling across the ship, and he's like trying to crawl to get the eyeball. Yeah. So those would be some of Sam's mishaps.
Oh, that's scary because all of those microscope parts, there's like so many lenses and delicate glass pieces in those parts that when you drop it, you feel like the world stops for a second and everything is like, oh shoot, is it okay?
Yes, completely agree with you there. Oh. But I take it you had no mishaps with the microscopes.
Never, of course, never. I did everything perfectly, never did anything wrong. Sure.
Figures.
I did break my slides as well, and I didn't drop the ocular thing, but I did take them out and was like, oh shoot, stuck it back in because I didn't know it was supposed to do that. But yeah, I think one of the more annoying things that happened to me a lot is like running through a whole program because I did a lot of fluorescence microscopy in my PhD. It took like, I don't know, 6 hours to prep a slide because you had to like dry it, stain it with this, wash it, stain it with the other thing, wash it. And it like took forever. And then you walk up from our like little lab up to the 6th floor where the big confocal microscope is that can deal with that fluorescent microscopy. And then there's like multiple things that happened. One time I dropped all of the slides that I prepared for like 7 hours and they all broke and I just went home.
Oh no. Yeah, that's bad. Oh man, even if it's not microscopy, I think anybody that's probably in the broader scientific community and probably life in general is familiar with putting a lot of hours into something and then you drop it and break it and you're like there was the PCR for 3 hours, there was the stupid gel for another 50 minutes, and then I'm on my way to the imager and it just sloughs off and rips into 14 bajillion pieces, and you just look at yourself like, yeah. And as I would joke with the mentees in the lab, I'm like, at some point, like we just go to Brahms and get ice cream. Like it's just not happening. Like we're at that point, folks. Like that, you know.
Yep. Ice cream is the only solution to that problem.
You know, we're at like DEF CON ice cream at that point. Like it's the only way that's happening. Oh man! Anything else?
We could do one last question before we call it for the day.
All right. What do you got?
Well, I was just thinking because we talked a bit about microscopy and what we use it for and stuff like that, but we didn't talk about what kind of microscopy we are doing. Because for our listeners, there's like, I think the one that jumps immediately to mind is just bright field microscopy. So the normal microscope where you have like a light source at the bottom and you have the stage where you put your slide and then the objectives and the ocular that goes not into your eyes, but your eyes like look through the ocular. And that is bright field microscopy, right? But then there's like all kinds of weird microscopy types.
Yeah.
So do you want to like describe some of the weird ones that you use?
Yeah, totally. So I will say I agree with you. I probably for the majority of my stuff, it's bright field. And if you haven't already listened to it, folks, at some point in this podcast venture, Julia and I ranked blindly our favorite microscopy techniques. And one of my favorites, I think, or maybe it wasn't favorite, it was importance, I think is what we ranked them, was scanning electron microscopy. And so scanning electron microscopy for me is probably one of the most important things that I do. Not that I'm actually the one doing all of it, but, you know, with respect to importance for manuscripts and things of that sort. So kudos to the grad students in the lab. And again, shout out, Lisa. You all are amazing and doing the lion's share of those 50 bajillion ethanol washes and all of those things that take 10 hours. But I really love scanning electron microscopy for measurement. So taking a very accurate measurement of cell size, looking for the presence or absence of and the arrangement of flagella. Endospore formation. Again, we can get sizes for the endospores. We can get very nice pictures of that bowling pin in terms of, you know, where is the rod bulging when it's producing this structure. And again, we can get really good measurements. And so I regularly use SEM. I love SEM. That's probably for me the weirdest one that I regularly use. Although I will say that I've got to delve into some TEM, some transmission electron microscopy, in the near future to help me in describing this isolate that we have that belongs to a novel order in the negativicutes. So negativicutes, for those of you that aren't intimately aware about this, they fall within the firmicutes. I mean, the Bacilliota. Sorry, I almost had a seizure there. That's for those of you that know about that inside joke. It's funny. For the rest of you, you're like, what the heck, Sam? Continue talking, or don't continue talking and just end the episode now. But the negativicutes reside within Bacilliota. And so for the most part, Bacilliota, they're gram positive. The negativicutes are gram negative, but they have kind of a cool, like in between cell wall situation going on where they do present as gram negative, but there's like more peptidoglycan in their peptidoglycan layer. And historically, in species description manuscripts, they characterize this little structure with TEM. And so I've never done TEM before, but that's something that I'm going to be doing in the very near future. Have you ever done TEM, Julia? Of course you have. She's just nodding like, yes.
Sorry.
We do all of this in Europe.
No. I was just very lucky that I got to do that.
Yeah. Okay. Well, all right, Miss Lucky. But I digress. That for me is probably what I would consider like special air quotes microscopy that's a bit on the extra side if we're talking, like multi-million-dollar pieces of equipment and programs and again the prep time and all of that stuff. It's probably SEM for me and soon to be TEM. What about you, Julia?
Nice.
What's special in your neck of the woods?
Yeah, I can't add anything onto that. Like special, I love doing electron microscopy, and I've done TEM and SEM as well. And I loved all the SEM we did for fungi. It's not necessary, but it adds a nice touch. Although for our recent publication that should be coming out soon, the 3 new novel genera, and Sam is like rolling his eyes, but you are on there. Your name is on there. Actually, there was one strain where it was really necessary to have an SEM image. Because SEMs usually, they give you the surface of whatever you're looking at. So with our anaerobic fungi, there's not much to be gained if you just do a regular SEM. But this fungus specifically was weird because out of its sporangia, it had like filaments growing. And usually filaments don't grow out of the sporangia. Like it had multiple filaments growing out of the sporangia, which we couldn't see with light microscopy or couldn't resolve with light microscopy, but you could see very clearly in the SEM images, as well as the multiple pores forming to release zoospores, which is also very unusual and has not been recorded for anaerobic fungi yet. So that's when we needed SEM to see those images.
Wow.
But mostly it's just nice looking at SEM images. And the TEM, the transmission electron microscopy, is where you kind of slice things up, and then you can also look get a closer look through the sample, so to say, because you have it sliced and all. We did that to kind of find methanogens on the surface of anaerobic fungi because there's like a close syntrophy between those kingdoms. But yeah, it was hard, and we're not sure what to do with the results yet.
Yeah, no, that was good. I'm glad that we took the time to talk about microscopy, and because it is so important, I think, in not just in microbiology as you alluded to, but in other fields as well, even outside of the biological sciences. Like I know oftentimes I see
physicists, like material scientists.
Like various geology and other disciplines as well that are needing to get at images for particular reasons and they're fascinating and I've said this before on here, but I'll say it again. And if you want nothing else to do with anaerobic fungi, do yourselves a favor and check out Julia's publication history. And in doing so, look at those images. that are in these manuscripts. If nothing else, it is a fantastic exercise in like abstract art. You stare at these just wonderful looking structures that I clearly know nothing about. We've established this and verbatim, but nonetheless, it's one of those things that it's so cool to look at them. And I don't think I've ever looked at an AGF image and been like not amazed by it. And so if you haven't, just Google like what does an anaerobic gut fungi look like or something like that. Toss in SEM and just take a look at it because they're really, really cool. There's some pretty daunting looking Kraken-esque figures.
Wow. I don't think I've ever heard such a positive spin on anaerobic fungi from your side. I think we roped you in
I don't know.
slowly but surely.
I will say I can't remember what it was, but I joked with Ty. I don't think he's ever successfully isolated an AGF, but he's like attempted to, like prior to me getting into the lab, and then I snatched him back over to the bacterial side of the fence, and I joked with him, and I was like, "All right, Ty, me and you, we should both give a like real serious go at this AGF thing, and then we're gonna pick this really weird random sample, and that's what we're gonna do." And needless to say, that has not happened because we're.
Well, I have complete trust in you, and I'm sure you guys will pull out a novel order of anaerobic fungi out of some of your samples.
Well, I mean, not to
You already
speak
did.
bad on upcoming publications. We'll have to work on some of the phylogenetic justifications there, I think. Oh man. But on that note, since we're talking about this AGF thing that I'm on, the bacterial one that you're on, it is officially,
it's live?
No, it's so I just finished we just finished messing with the proofs about what is today, Wednesday, so it was maybe 2 days ago. I think it was Monday.
That is so crazy. We're so head to head with those publications. Like I think we submitted them at approximately the same time. Then the reviews came back at the same time, and now the proofs went in approximately at the same time.
Yeah, that'll be. I wouldn't be surprised if they're in like the same issue when it's all said and done. But yeah,
nice. Isn't that lovely? You and I,
lovely
on the manuscript of each other in the same issue of that lovely journal.
Exactly. I know. That isn't that lovely. That's just about like getting bless your hearted. That was there was a lot of love that went into that statement, folks. I mean, I know that you're just listening, but man.
I meant it. That was not a bless your heart situation. I really meant it.
Yeah. Okay. I don't know that I have anything else to add to that, Julia. I really enjoyed. It's always a pleasure to sit down and to chat with you about all things, whether it's Life Unculturable or not. Just catching up, and I'm trying to think. If you're out there and you are just telling yourself, "Man, how can I get more of this Life Unculturable stuff?" Well, do I have news for you? You can find us anywhere out there on the internet, kids. YouTube, Spotify, Audible, wherever you listen to your podcasts, we're out there. And you'll also find us on LinkedIn. You'll find us on Blue Sky. You'll find us on Instagram. And we're out there. We're about there. We're looking forward to being
13 more episodes 12 more episodes for you to listen to in the bank. And more are coming.
More are coming. We've got some really fantastic interviews lined up, and we've got some, dare I call Julia and I, our solo episodes fantastic, but we've got some cool topics to discuss, and we're excited to do that. And should we tell the people that we're taking a break?
Yes.
Yeah,
probably a good idea. So there will be a very short break in publishing new episodes. So August 2026. There will be no new episode coming out.
Well, Yes, we will still be posting content on our social media accounts, but Julia is correct. We will deprive you all of 2 episodes during the month of August. And so we will hope that that distance makes the heart grow fonder. And
Yes.
whilst you're waiting for content, so perhaps Mom, this is you again if you're out there listening. Which I know you are, you can just re-listen to one of your favorites from the vault. Yeah, no, that's crazy. 13 episodes in. Man, what a trip it's been. It's been a blast, and I'm still having fun. I hope I'm still having fun. We get Michael on the podcast very soon.
Yes, so finally our listeners get to meet Michael, the elusive Michael.
Yep, he does exist, allegedly. I saw a photo the other day, so, could have been AI, but it didn't look like it.
We dragged him in front of the camera, and you'll be seeing that episode very soon as well.
Yeah, no, that's good fun. That's really good fun.
Yeah, It is. Well, I think with that, we've said it all for today. I'm very much looking forward to the next week, which will be a recording intense week. We've got a couple episodes lined up.
I know we've got 2. I think it'll be the first time we've recorded twice in 1 week.
Yes.
So, man, we're gonna run out of things to say. What is?
I see no chance of that happening.
No, I know, man. On that note, Julia, have an absolutely lovely rest of your early evening, pre-evening, and we'll be talking soon.
Well, it was lovely talking to you. I'm glad you had a blast at the conference, and next time we're going to talk a bit more.
Totally. Wow. Well, I suppose I should get into the lab and do something before the end of the day is here. The end is nigh. All right.
Back to the lab.
Next time.
Until next time.
Back to the lab. All right. Well, I will catch you later, Drew. Bye.